Okay, so hopefully you had an opportunity to work through this example. And what I'll do is I'll work through with you just to make sure it's okay. So we have the upper leg length of a 20 to 29-year-old male is normally distributed. The mean length is 43.7. All right, so right here, this is telling us that the mean is 43.7 centimeters. Standard deviation is given as 4.2. And then finally, the number of samples, so standard deviation 4.2, and then 169 males were surveyed, were sampled. So if you recall our formulas, mu sub x bar is equal to mu, which is 100, I'm sorry, excuse me, it's going to be 43.7. All right, so that one's really easy. You just look at the problem that was given, and mu sub x bar are always the same for the sampling distribution. Now sigma sub x bar, we had a little bit more complex formula, but not too bad. Sigma over square root of n. Sigma in this case is 4.2. N is 169, so I'm going to have 4.2 over the square root of 169, and I get 0.3231. Okay. Now remember, if you round differently, you might get slightly different answers than I do. Doesn't mean you've done anything wrong. All right. So that should be really easy for part A. All right, and those are always fairly easy types of problems no matter what. Find the probability that the average leg length is less than 43.6 centimeters. Okay, so if I was to construct this, just to give you an idea as to what this looks like on a normal distribution. So here's our distribution. In the middle is that 43.7, and then we have 43.6 as the value that we're interested in, and we're interested in everything that is less than that 43.6. Okay, so we're just going to shade all of this area under the curve, and that is what we are left with. Remember our formula, z is equal to x minus mu sub x bar divided by sigma x bar. If we substitute back in, z is going to be equal to 43.6 minus 43.7. We found that the standard deviation was 0.3231. I'll punch that into the calculator, and I get negative 0.31 if I was to round that to 2 decimal places. Now, I'm going to convert that. We're going to use our z-table. And the z-table for negative 0.31, if I look that up correctly, and again, you should verify this, 3783. At the end, what I'll do is I will type out what these actually mean once again with respect to the context of the problem. For letter C, find the probability that the average leg length is more than 43.9 centimeters. Distribution. Again in the middle, we have our 43.7, 43.9 is the value of interest, and this time we want more than. Right? So if we get like a 90% or an 80%, it's not good. Formula for z, same thing as above, x minus mu sub x bar divided by sigma x bar. That's an x bar, sorry. We'll get rid of that and we'll draw it again. There we go. So in this case, that's going to be equal to 43.9 minus 43.7. We're going to divide that by the 0.3231. Now, let's figure out what that is. And we put that into our calculator. I got 0.62. We're going to convert that using the z-table. I get 73.24. And then finally, we can't forget that for a more than problem, we have to take the complement of whatever we get for that z. So in this case, the final answer is going to be 1 minus 0.7324, which I believe, if you guys would verify this, that should be 2676. In fact, I'll do that just to be certain. And I got 2676. Okay. So once again, that's our probability of just the 169 males. All right. Now finally, we want to know what's the probability that the average leg length is between 44.5 and 45.5. We have a between problem. So 43.7, we have 44.5, and then we have 45.5, and that's our between. All right, so this is what we should be looking at. Now, we have to do two z's, so I'm going to find z sub 1, z sub 2, and then subtract for between. Okay, so z1, I always take the bigger number. So 45.5 minus 43.7 divided by 0.3231. Z2, that's going to be 44.5 minus 43.7 divided by 0.3231. I'm going to shove both those into the calculator. So for the first one, I got 5.57. For the second one, sorry, my batteries are dying. I got 2.48, excuse me. All right, now I'm going to convert both of these using the z table. Right? Now I notice that 5.57 is not anywhere on the z table. Right? So you have to remember that anything greater, if z is greater than or equal to 3.90, then remember the area is approximately 1. Okay? So we're just going to say that that's going to be 1 for all intents and purposes. 2.48, I'm going to go into the z table, and I get 99.34. All right. Finally, for a between area, 1 minus 99.34, that should be 0.0066 for the probability. All right. And so let's just recall what all this means now. Okay, so we have our three probabilities, and I'm just going to copy and paste these. So let me turn this draw off. So that way we can see what it is that we're actually getting. Ignore the proportion stuff for right now. Okay, so the probability that the average leg length, and this should be of the 169 males, is less than 43.6 centimeters, and that's going to be this 3738. Okay. The probability of the 169 males, the average leg length of the 169 males is more than, and that should be that 2676. And then finally, again, the average leg length of the 169 males is between that is the 0.0066. Okay, so it's not, again, not very likely that this last event is going to occur.